For some reason, the recording didn't record, so I'm going to do it again, run through some stuff real quick. To summarize, again, if we do our Schoology tour, looking at this week, I really want you, again, watch these videos and then do this Desmo activity. So this, the Connect will be shorter, but I really want, again, I'm giving you time. I want you to do this activity. This activity will really help you understand sort of at least amplitude and part of the sine graphs. So really work. Again, I'm going to give you time. This is part of your weekly work anyways, but I really want you to spend time and try this Desmos activity out. Reflect on it. There's another assignment. It's about inverse. So lesson 5 and 6 are very related. Next week, we're going to review. So again, we'll spend a decent amount of time reviewing. You'll get some IXL practice. And we'll finish up Unit 4 here. And then the last week before winter break, we will do a project. So again, everything's kind of related here to the sine and cosine graphs. We will have a Class Connect next week. I want to talk about the project. So in our Class Connect next week, we'll talk about this project. Otherwise, for this week, really what we kind of focused on is, again, these things called sine graphs. You can see as this circle is moving, I like it when it moves on its own, but as this point moves along our unit circle, you can see how that correlates to the sine graph. Right here, it's at its positive. Again, sine is y. This would be a 1. Over here, we get to where on our circle, y is 0. That's when we get our x-intercept, and we're going all the way around. So it takes one whole rotation around the circle to get a full rotation, to get it to repeat. And we'll talk about that. Here's another example. Let's see here. Bring this up. Drop it. Okay, you can see how my amplitude sort of starts getting smaller. That's because my dampening is really small. If I take it again, drop. This continues to bounce again. This would be an example of like a sine wave in real life. Less stiff. It's going to take longer. Ooh. Maybe we increase the dampening. This is something you got to know how to graph a sine graph. Again, the period or how long it takes to rotate is 2 pi radians, also known as 360 degrees. So if I start at 0, I'm not going to repeat until I get to 2 pi or until I get to 360 degrees. Similarly, if I start at negative 2 pi, I'm not going to repeat until I get to 0. So that's kind of the gist of our sine graph. Our cosine graph, you can see it's very similar, but it's shifted over pi over 2 units, which if we look at them combined together, you can see how they're extremely similar. But cosine crosses at 0, whereas sine crosses, or it's at its maximum at pi over 2. So slight difference there. Again, to understand the difference between sine and cosine is really important. Tangent, sine over cosine. We end up getting some asymptotes, which again are these dotted lines, which means it'll never cross. And it is repeats. So the period of a sine graph is really every pi units. So again, from negative 3 pi over 2 to negative pi over 2. From negative pi over 2 to positive pi over 2. That's 1 pi or 180 degrees before it rotates. And then inverse. So again, if I were to take this portion of my sine and flip it, swap my y's and x's, I would get, looks very similar to the tangent graph, but notice my domain and ranges are different. Here my domain is negative 1 to 1. My range is 1/2 to negative 1/2. Similar over here, but again, cosine, it's like it's the opposite. It's kind of the mirrored, where, okay, if I go from negative 1 to 1 here, this time I'm going from pi to 0. And then cotangent, again, inverse tangent is cotangent. It's flipped. Or this is not cotangent, this is the inverse, excuse me, where we swap our y's and x's. And now we are fluctuating from 1/2 pi to negative 1/2 pi, which is like 90 and 90. You can see how the cosine and inverse cosine are somewhat related. Basically, if I took this section here to here, I could flip it, swap my y's and x's, and it'd look something like this. Just another example of one period of the sine graph, one period of the cosine graph, and then seeing where they cross and how they're different. Amplitude describes how high up it goes. Period describes how long it takes to repeat. There's just a different way of looking at our tangent graph. Again, we've got asymptotes here and here. Remember, cosecant is the kind of opposite of sine. Cosecant is the inverse of cosine, and cotangent is the inverse of tangent. So their graphs are going to be similar. Amplitude just talked about. Period, how long it takes to repeat. For amplitude, it starts at 0. So how high up it goes from 0. We don't count from the highest point to the lowest point. That would be twice as big. So you can go from either the lowest to 0, or you can go from 0 to the highest, but you can't count them both. Phase shifts would be shifting left and right. Vertical shifts would be shifting up and down. So that's where, again, we talk about A's, B's, C's, and D's in our equation. Like A cosine BX plus D. That's where we get these. A is for amplitude. The B is for affects the period. The C moves it left and right. And the D is a vertical shift. And so here we can see all of our graphs, our sine curve, our cosine curve, our tangent, and then the inverse sine is cosecant, secant, cotangent. Again, real fast overview. I really want you to spend your time using this Desmos activity. For your Class Connect assignment, your folder's right here. Okay, if we open it up, I want you to show me, prove to me that you know what each of these graphs looks like. So which graph is a sine graph, a tangent, cosine. Fill that out, and then make sure to complete the Desmos activity.